Now we're going to upgrade the headlights and the tail lights, and also the little parking light right here. I guess they call it a clearance light, depending whatever you want to call it. We're going to be doing just those 3 bulbs per side, so 6 bulbs total. And we're doing this for a couple reasons. One of it is for efficiency. Another reason is because the performance is better. So what I've got here is, seems to be best to just take this off as a unit. It makes it easier to access everything. The little bulb down below in particular is hard to get to with it in place here. So this is what I've got here. So the headlights are H4U is what they're called here. Show it to you here. H4U, and it says 60 watt, 55 watt. They have a particular beam pattern here, or the filaments are a particular pattern there, as you can see. The one in front appears to be the low beam, and then the one in the back is the high beam. But what's interesting is I bench tested this. It says 60-55. I tested it, and it came out to be 58 watts on the low beam and then 69 on the high beam. So I'm not sure where they got these numbers or what is going on with that, but because I would automatically assume that the first number would be the low beam and the second number would be the high beam. But anyway, that's what I've just bench tested. So now granted, I'm bench testing at 13.1 volts, which is pretty high. That's a fully charged battery, but nevertheless 58-69 is what I got. So it's interesting. Lots of heat being produced when you run these old halogen bulbs. Now our new bulb is going to be an LED. It has a fan on it, which is preferred. You always want to have the fan because it keeps the cooling, has better cooling performance. And so it appears to have the same. These two are going to be pointing upwards, and then it has the bottom one that's offset a little bit back and pointing down. That's the high beam. So what happens is on high beam mode, all 3 of them come on equally, and then when it's in low beam mode, the upper 2 come on, but they come on a little bit brighter. Because I just tested that, and it turns out that there's 26 watts on low beam and 26 watts on high beam. So that's pretty bright for LED. Usually these things are at least 4 or 5 times more efficient per wattage. So I'm estimating just by looking at it and by the voltages or the wattages that I've pulled on this thing, that it's going to be at least twice as bright as that, and it uses half the power. So that's what I'm talking about here. So we got more efficient use of power, and it also is going to be twice as bright, so better performance. And then this is the little ones in the little parking light. These things also use about 1/8 the power. That's like 4 watts. This is like 0.7, 0.66 or something like that. And then for our tail light brake light combo, this is a 521, so 5 watt in tail light mode, 21 in brake light mode. Our replacement puts out only 0.8 watts when it's in tail light mode, and it puts out 3.9 when it's in brake light mode. And the thing is, once again, these are significantly brighter. I mean, really brighter than the other ones. And they're fast too, because when you hit that brake light, I mean, it comes on instantly. So it's like super fast, so you get better performance, brighter bulb for a fraction of the energy. And so let's go ahead and put these in the car and see what they look like. So this is the clearance / parking lights on. I like how these illuminate the whole bulb. It almost looks like the headlights are on, but they're not. It's just the parking light mode. But as you can see, the color is different. It's a little bit brighter, I believe. Not so candlelight looking like that one. It's definitely more modern. Now you can get amber bulbs if you don't like the amber, or if you don't like the bluer tone and want to go with more of a retro look, which would be kind of cool to put amber bulb in. It might kind of give it more of a French car look from the 80s or 70s. Really, really dim. I mean, there's nothing bouncing on the wall at all here. On this side, we've got the LED, which is quite a bit brighter. As you can see, all that light hitting the wall back there, whereas on this side, nothing. So let me go ahead and I'll show you the brake lights. Notice the delay when you put on the brake lights, how the LED one is so much faster. Now let's go ahead and put on the headlights. Once again, faster response time. Stand in front of this one, it's like, look at the difference in the light there. If I stand in front of this one, everything turns brown, right? Look at that. Quite a bit brighter. That's definitely going to be nice, enjoyable to drive at night. So anyway, that's the LED upgrade. Now that we replaced our lighting with LED, it's drawing the attention to other things that need attention here as far as lenses. As you can see here, how dull that is right there. This is how all of them are, the front and the rear. And so what I've done is I've applied some product to it. Some Plastex is what it's called. And notice the difference there. See how that's nice and shiny and glossy again? And that's just one coat too. I'll show you the back here. So this is the before. As you can see, really dull, hazy, cloudy, pretty nasty looking. That's how all of them were looking, all 8 of them. And then this is the after right here. See how much of a difference that is? It's nice and glossy and shiny, it has nice color. It's not all hazy and smoked out. And so this is the product right here. It works great on plastic headlights too. Next we're going to focus our attention on more restoration stuff. So we have some badly damaged clear coat right here, as you can tell. It appears to be just a clear coat. It looks like our base coat is still intact here, so we should be able to just lightly sand this down. And we'll mask everything off, of course. It looks like we can just do it all right here because this is the only place it occurs. So kind of ugly, but I think we can fix it with some nice new fresh clear coat. It's kind of tricky to get it to take off the clear coat but not the paint. And so I'm finding one of the better techniques is to use a razor blade and tools such as so. And you can kind of just scrape it off like that. It's working really, really well. I should have just went straight to that. You can see how that just comes right off. Because otherwise you get a bunch of this flaky stuff on here. We've still got pieces of it here after sanding and washing. You just do like this. You can kind of see that it actually effectively does a really nice job here. And then we'll be able to lightly sand again. Have a nice even sanding the next time. And then wash it down again. And then we'll be ready. This is what it looks like when you get all that nasty roughness off there. Still got a little bit to do here, but it's coming out pretty nice. It's nice and smooth over here now, whereas before it was still rough. So we want a nice smooth finish because the clear coat's not going to hide any of it, so it's only going to emphasize it. So if it's still rough, it's still going to be rough even with the new finish on it. So we want to make sure it's nice and smooth as possible. So we did light sandpaper job, 220 grit, like we did before, except we just did it again. And that kind of gives us a nice smooth finish now. Pretty much ready for paint. I just wiped it down. That's why it's a little wet right now. Here's what it's looking like after the third coat. We waited a few days before doing this. Let it thoroughly dry. It was about 4 days actually. And then we went ahead and hit it again. So yeah, I think it's looking pretty good now. So the next thing I've been working on is I've been cleaning up the back area here. There was a little bit of surface rust on here, so I cleared all that out. Looks like we have a little bit of a rust spot right here. Might want to stick some caulk or maybe spray a little paint on there just to stabilize it, keep any more moisture from getting in there. But otherwise, it's looking pretty good back here. I've gone ahead and reinstalled our trim piece back here, so our access panel's in, because we've got this in place now. So that's what that's looking like. So it's nicely coordinated, color coordinated with our bumper down here. So that's looking pretty good. And then of course this is all coming after finishing our our clear coat up here, which now looks too shiny because it's shinier than everything else. It's the, it's the shiniest part of the car now, unfortunately. And there's a little bit of orange peel. We could probably buff that out. I've seen other people do it, so I'm sure we could do the same thing if we wanted to. I'm not sure if it's going to be necessary on this car, but something that we could possibly do. I figure that this will go out just as soon as you wash it a couple times and you get a little grit on your, just a little bit of just dust and stuff will even it out. So I think it looks pretty good for what we wanted here. So this is what our wheel covers are looking like nowadays. They've been freshly painted, 3 coats. It came out pretty good. Some of them still have scratches on it. I didn't realize how badly that was scratched. I could have sanded it down. There's actually room to sand it further. So if one wanted to and make them look even better, you could. But I figure for the purpose of how this car appears, I think it's going to be just fine. You know, it's down here, it's by the wheel. We're kind of going for kind of a patina look on this car anyway. It's not a show car. Well, it will be a show car, but it's going to be a patina type of show car. So with that being done, I think that's pretty much it for the restoration. Okay, continuing to make progress here. We got a lot of this original wiring back in wiring loom, back to its original location. No further need to mess with that. That's all been tested. It all works. Everything that's there has a purpose. So now we're going to focus on new stuff here. So we got our new 12-volt battery right here. This is approximately, I'm just loosely placing it in here. It's approximately where we want it to be. I think that's going to be a good location. Oh yeah, I also relocated the relay. There was a relay over here that was back over here. This little cluster right here. So I just kind of push that out of the way a little bit more. It's going to give us more access here for other things. So what we're going to do now is figure out a way to mount this on here. Looks like we'll be able to just strap it. We have some hooks right here. We've got a little screw down here. I think we could just run a strap across there and that'll be that. This thing doesn't weigh but not even 4 pounds, so it's pretty light. And then we're going to go ahead and fit our DC to DC converter. This is what we're using here for this build. So the purpose of this is it's a 96 volt converter to 12 volt. So it converts your battery pack here. So, you know, this is a 96 volt pack times 2. It would take power from here and then convert it over to 12 volt power to charge this, to keep this one charged up. Because otherwise the 12 volt battery may run out of power relatively quickly. It just depends on what you're doing. If you have all the headlights on, if you have the radio on, just for a lengthy period of time, eventually the 12 volt battery will run out. So you have to be able to replenish it with power. So, and that's what this does. So we're going to try to fit this right here. It looks like I think we can build a little bar across here using our existing holes, and then have a place to strap it to. And I think we just strap it down, put some padding on it, and I think it will be good to go. So I got these 2 items installed now. It came out pretty good. Got a battery in right here. I just basically put some padding down underneath of it, some foam stuff that came with the battery. It's the same kind of stuff as this right here. And I just used a couple cable ties here. Very happy day here, finally. We have some boxes. But what's more important is what we have inside. So this is our motor here. Finally, 2 whole months later since I ordered it, finally got here. Had numerous delays, numerous problems. So here's our motor. As you can see, it's a pretty nice unit. I'm very happy with the quality of these. This is my second motor I bought from this company. So it's manufactured in the US. It's made by a company called HP EVS. And this is the AC35 model. And this is the specs right here. So as you can see, it's pretty interesting power output here. So this is the torque, this is the horsepower. So as you can see, between 0 and 3,000 RPM, it really has a lot of torque. It has about 129 to about 121 or so pounds of torque. Pretty relatively flat there in that range there. And then the horsepower builds up from next to nothing at 0 up to 63. So as you know, the PAO has a 50 horsepower engine when it was new, and it has a 55 pounds of torque when it was new, and this has well over twice that. So you know how the old saying goes, horsepower will sell a car, but torque wins the race. And in this particular case, we've got well over twice the pounds of torque here, relatively flat band there. So it's going to have, I think this car is going to be quite a screamer. That's what I'm going to project here. Even though the 63 horsepower is not super great improvement, it's the torque that really matters here. Also, I'm thinking if somebody really wants to roll through the gears here, you could probably optimize that power. You know, just being a manual transmission, you could rev it up to 4,000 RPM, shift it, and it would bring the RPMs back down to 3,000, or actually maybe 3,500. Shift at 3,500, brings the RPMs back to 2,500. You rev it up again, shift at 3,500 back, brings it back down to 25. You would effectively keep that torque right at maximum, the torque and the horsepower in the maximum range there. So that would be an interesting experience. So we'll have to play around with that and see if we want to shift the transmission or not. My philosophy's been I just want to pick a gear and stick with it. And this is the controller that we're going to be using. This is a Curtis 1238 SE, 96 volt, 650 amp. So it's a very nice quality controller. A lot of people have used these for years with no problems whatsoever. So it's highly reliable, cost effective. The one thing you have to make sure with this particular controller is that you keep it cool, because they do tend to get hot. So I went ahead and got the air cooled, and this is what we have here. It's it's basically a heat sink. It's an aluminum heat sink is what it is. So it's the air cooled system. So you basically just put it on there like so. And because we're going to be mounting this controller, you always want to make sure the controller is mounted right up against the motor. You want these three wires right here that go in to here. You want them to be as close as possible, as short as possible. So it was always my intention to put the controller right out front here. So as I looked at it further, when I started to realize that, okay, maybe this liquid cooling thing might not be happening here, I thought, well, why don't we just do a little experiment here? Why don't we just go ahead and get the readily available air-cooled plate here, the heat sink, get that instead. And since I know I'm going to be mounting it right out front here, you know, this thing is basically going to be right here in this area right here. So it's going to be right behind the grill. So it's going to be very effective at cooling, at least from air. So it will be an exercise that we'll be able to monitor and just see what actually happens. And if it turns out that the controller is getting warm, you know, too warm, then I'll just shut off the car and I'll let it cool down, and I'll come home and I'll say, okay, well, this ain't working. Well, let's just toss it and we'll go ahead and do a water cooled system as originally intended. And so there's basically two critical parts that have to happen here. Everything else is pretty much subjective, but these are the two most important things that have to happen. So you have to be able to replace the engine with your motor. And so there's two things that have to happen here. So you have to connect the motor directly into the transmission, and then you also have to physically mount the motor either to the transmission and or to the car with mounts. So that's the two things that we're going to discuss right now. So the first thing we're going to do here is discuss how we actually attach our power output of the motor here into our transmission. And so the easiest way to do it is, this is a manual transmission car, so what we have here is we have our clutch disc right here. So we're not going to need that anymore. But there is one part of this that we want to keep, and that is this piece right here, this splined area right there, because we know for a fact that goes into our existing transmission shaft. Now, in an ideal world, we could have our motor shaft match that, and then that way we wouldn't have to do an adapter at all. All we'd have to do is just mount our motor, line it up and mount it to our transmission somehow, or to the car with mounts. But that would be in an ideal world. We're not living in an ideal world, so this motor only has certain options here. This is pretty much the standard one right here. So what we have here is we have an 1 1/8" shaft coming out with a 1/4 inch key. And so, but the good thing is that is a common size. So we are able to get couplings and adapters and such, and that's what we have right here. So I was able to find this online. It's some old part, some coupling for something. I'm not exactly sure what, but it doesn't matter because it fits our shaft perfectly. It's 1 1/8" Browning piece right here. So I think, I don't know, it might have been for a printing press or something wherever they would have used a high horsepower motor to you know, to drive something. So what happens is that this fits on here nice and precise. They have a nice round edge there. So basically, you can see right here that there's a little rounded edge at the end there. So basically, you just insert your keys like so, and it fits in there nice and precise. And then all you have to do now is just tighten down that screw when you get the position where you want it. So this allows a little bit of flexibility here. We can go in, you know, as much as that, or we can have it stick out as much as maybe right around here. So we have about a good maybe 1/2 inch of play there. So that's good. So because we have to make this motor, you know, we're going to have an adapter plate right here. So it's going to be sticking into the transmission housing and then mate with our transmission shaft that's coming out right here. We don't know exactly what we're going to take a dimension right now and find out exactly what that needs to be. But then as far as on the transmission side, we know this fits, so that's going into our transmission. So all we're going to do is, all we're going to salvage from this, we're going to take this apart, drill out these rivets here and take all this apart and see how much of this we can take down here. But all we really need is this centerpiece here, and then maybe a little piece of plate. And then we should be able to just simply take that out. We should be able to just basically cut this down to what we need to and just simply mate that on there. And once we find our center line for both pieces, we should be able to weld that together. So here's what the clutch looks like once it's disassembled here. So we drilled out those 4 rivets right here, and this is all came apart nicely now. So we have basically, this is the only piece we really need right here. This is what connects to the transmission. And then so our piece that we just took off from the clutch is this piece right here, and of course it goes on nice and precise like so. And so the next step after you do that is to take some dimensions. Now it turns out that we have a little bit of a conflict here of about 24 millimeters or so, maybe 25, 26, so about an inch. So what we have here is we have, in relationship to where the plate's going to be, these 2 shafts are basically overlapping into each other. We could take off a 1/2 inch of this here shaft and just cut it off, although getting to it would be really difficult because I don't know how I would get to it. It's kind of hard to get to unless I have like a right angle grinding wheel or something. And then the same thing would have to happen here. You have to take about a 1/2 inch off right here because we want to make sure that we have full contact. We don't want to have any compromise on the contact area. So, but there just happens to be about a 1/2 inch, maybe 5/8 of an inch extra on each of the pieces here. So that is one option. The other option is, of course, is to add an inch and just basically to have the whole motor, instead of it being flush with the transmission housing, it would basically offset 1 inch and just have it all push out, and that would give us enough room. So I just finished using the old angle grinder to cut off this extra metal that we don't need, so that's gone. And that leaves us with just this little piece right here. Went ahead and sanded it down and cleaned it up a bit. So that is basically ready to go now. We should be able to just take this to a machine shop. Any reputable machine shop should be able to center this up and get it super precise and weld it up. And then that will be done and ready to go.